Hello students, how are you? I hope you are all in good health. So let us start with the next chapter, that is chapter light for your 10th class. In chapter light, we have to study two phenomena related to light, that is reflection and refraction. So these two phenomena we have to study in this chapter. Okay, before going to the details of these phenomena, I would like to introduce you about light. Now what is light? Light is nothing but a form of energy. Light is a form of energy. Light energy that we call usually. It is very common term. So light has particular characteristics. In our daily life, it is very important to see things. If we are in a dark room without any light, or in the night time, you can say, we cannot see things clearly. So light is very important to see things. For vision, you can say it is very important. Why? Because whenever any object is reflecting light, fall on it. For example, sunlight, when it falls on any object, it reflects and it comes into our eyes. And because of these phenomena, we will be understanding in this chapter and the next chapter. Because of these phenomena, our eyes are able to make an image of that object, and that is how we are able to see. Okay. So it's very important to study light in our daily life. It has a very great important role. So first of all, I would like to introduce the characteristics of light. What are the main characteristics of light, which is a particular form of energy? First and foremost important characteristic is that light has a dual nature. Dual nature means it can travel in the form of wave, that is called as wave nature, and also it can travel in the form of particles, light particles that we call. So it will lead to particle nature of the light. Okay, so light has dual nature, wave nature and particle nature. Some phenomena that we can explain with the help of wave nature, and some phenomena are there which we can explain with the help of particle nature of light. So in this case, in this chapter, we are going to study two phenomena, I told you, and these two phenomena are based on particle nature of the light. Okay, so we are going to deal with the particle nature only. Wave nature, about wave nature and the phenomena related to that, we will be dealing in your higher classes. Okay, in class 12 you will be going to study about that. Second is, light can travel in medium as well as in vacuum also. That means without any medium also it can travel, or in any medium also it can travel. So light can travel in vacuum as well as any other medium, and it should be a transparent medium that we know. Okay, the third important characteristic of light is that it can travel in straight line. And when light is traveling as a particle, that means the particles are moving in a straight line. Okay, fourth property is the speed of the light. Speed of the light in vacuum, I will tell you, is 3 multiplied by 10 to the power 8 meter per second. Okay. Here I will tell you what do you mean by traveling. Traveling means moving, that we know. And in case of the light, we consider this as a important term, and that is considered, and that will be we will be calling as propagation. Propagation of light. Propagation means moving of light from one place to another place. Propagation means traveling of the light. So this term is important term, and you will come across the term many times in this chapter. Okay, now come to the main important part of the chapter, that is reflection. So first of all we will consider reflection. So light can reflect, we know, from the polished surfaces. We all know this thing, we have studied in our lower classes. Polished surfaces, the silver polished surfaces are there, like a plane mirror, or some new spoon you can see, or some new utensils you can see. If it is polished newly, so we can see our reflection over there. So plane mirror is one of the example. In the case of mirrors, the polished surface is a silver polish, that we know. Okay, and light can reflect from plane surfaces or plane mirrors also, and it can reflect from the spherical or curved surfaces also. So spherical surfaces or curved surfaces also, so those are called spherical mirrors or curved mirrors, we can see. So spherical mirrors are of two types. I think we know it, earlier we have studied. These are concave mirror and convex mirrors. They are of two types, concave mirror and convex mirrors. So before going to the details of concave and convex mirrors, I would like to show you how the image is formed in the case of plane mirror. So image formation in the case of plane mirrors. Image formation depends upon the reflection, and we all know what are the laws of reflection. Let us recall the laws of reflection. Laws of reflection has two parts, first part and the second part. In the case of first part, we all say that angle of incidence, angle I, is always equals to angle R, angle of reflection. And the second law says that incident ray incident ray reflected ray and the normal, all three should lie in one plane. So laws of reflection we should recall before going to for the image formation in the case of plane mirror or in any case. Okay, so plane mirror I will draw over here. Let us say this is a plane mirror and this is a painted part. The dashed part is a painted part and this is a polished part. So this part will reflect the light, so we will keep our object over this side. Okay, so from the center I will draw a principal axis which is perpendicular to the plane mirror. Okay, let us say our object is placed over here, or we are standing in front of plane mirror like this. Okay, so light reflected from the object, if it is traveling in the straight line parallel to the principal axis, that light we will consider. This will reflect back, making an angle same as angle of incidence. What is the angle of incidence? Let me specify over here. Angle of incidence, when there is a surface like this, angle of incidence is the angle which is made by the incident ray with the normal. This is a normal. So this angle is angle of incidence, and the reflected ray goes like this, angle R. So reflected ray is like this. So if this is incident ray, I was saying, and this is reflected ray, the angle of incidence is between incident ray and the normal. Angle of reflection is between reflected ray and the normal. So here what is angle of incidence? The angle of incidence will be 0 because it is perpendicular and it is along the normal. Like here, if it is along the normal, the angle of incidence will be 0. So here angle of incidence is 0, so it will reflect with the same angle 0. So it will follow the same path in the backward direction. So reflected ray will be like this, because angle I should be equal to angle R. Okay. Now another ray, if I consider like this, suppose this is a normal, any perpendicular to the surface will be normal. So along this normal, this is angle of incidence, angle I, and according to this, angle of reflection will be same. So reflected ray will be like this. Okay, so this is R, this is I. Fine. Now this is one reflected ray, this is another reflected ray. These two reflected rays will not meet over this side because they are moving away. If I extend this and if I extend this, they will be going to away from each other, but they can meet virtually at the back side of the mirror if I extend backward. Okay, extend it backward like this. I am extending, so it will be making an image which is a virtual image, and it is behind the mirror. Okay, so the image formation will be virtual image, and it will be erect image. What type of image the plane mirror will form? It will be virtual and erect image, and the image will be of same size as the size of the object, and the image will be at the same distance as the object distance. So object distance and the image distance will be same. The object distance is actually called small u, and the image distance is actually called small v in terms of the in terms of this chapter, you can say, in terms of physics, you can say. Okay, so from distance from the mirror to the object is u, distance from the mirror to the image is v. So the distances u and v are same, u is equal to v. Okay, and the fourth important property of this kind of image is this image is laterally inverted. So this image is laterally inverted. Okay, so these are the four important properties of the image formed by the plane mirrors. Okay, so in this video we have introduced about what is light and the different characteristics of light, and the reflection property, the laws of reflection, and the image formation by a plane mirror. Next type of mirrors are spherical mirrors, in which we will deal with concave mirror and convex mirror, that we will cover up in the next video. Hope you understood this video. Thank you.